Hello everyone, this is Upal Manikumar of CSITA having rule number 22951A3352. Today's my topic of concept in BW is star to delta transformation. What is star delta transformation? It is a transformation of star connection to the delta connection. As you can see in the picture, in the picture 1 there is a star connection, in this picture 2 there is a delta connection. It is called star to delta transformation. Learning outcome. After completing this concept video, we will be able to understand the following: how to convert star to delta transformation. We know about the star and delta networks. Introduction. In electrical systems, we have to deal with resistors a lot, arranged in different I parallel, series, mesh, etc. Simple single-phase resistive circuits where resistance are present in parallel or series combination can be solved by using series or parallel formulas by resistance. There are also few other techniques like Kirchhoff's law, nodal analysis, etc. to solve such circuits, but in the case of complex three-phase resistive circuits, we can use these basic formulas and thus need better techniques. Star to delta transformation method is one of them. The star to delta transformation can also be expressed as Y to delta transformation. It is a mathematical method used to solve complex resistive circuits in three-phase electrical systems. Its name via delta is given to be it because two of its design, as shown in the figure, star WYE looks like Y, while delta looks like A. This transformation technique from one form to another form was given by Edwin Kenley in 1899, who was an electrical engineer who belongs to the USA. Besides using in electrical circuits, star-delta transformation can also be used in math to solve different planar graphs. In today's post, we will have a look at this working formula, equation, and uses. So let's get started with what is star-delta transformation. Any network can be converted into two special type of network is known as star and delta networks. Why star delta transformation? We use star delta transformation to simplify complex three-phase circuits. These simplified versions are a lot easier to solve as compared to the original complex ones. So such transformations actually save us from complex calculations, thus reduce errors and save time. Now let's have a look at star and delta arrangements one by one. In the above figure shows the T-shaped normal circuit and its equivalent Y-shaped connection. If all resistors are connected to a common point from one end while the other end is open, this connection styling is termed as star network or Y connection, as called WYE circuitry. Star connection is also referred to as open loop, as there's no loop in it. We have not performed any transformation in the above figure. Instead of, we have just drawn a single circuit in two different styles. One is called T-shaped while the second one is Y-shaped. In both of these forms, resistors are connected at a single common point called junction joint, represented by J in the above figure. Now let's have a look at how delta network look like. Below figure shows the normal loop circuit and its equivalent delta circuit. If the resistance are creating a loop, i.e. each end of resistance is connected to other resistance, such circuitry is termed as delta circuitry. Delta connection network or delta connection, denoted by A. Delta connection is also referred to as a closed loop, involves a loop. Equation of star-delta transformation. As shown in the above figure, we need to find the values of delta resistance. In order to do so, let's find out the resistance between nodes between N1 and N2. In star correction, the resistance between N1 and N2 is equal to R1 plus R2. In delta connection, resistance Ra is in parallel with Rb and Rc. So the resistance between N1 and N2 will be equal to Ra into Rb plus Rc by Ra plus Rb plus Rc using resistance parallel formula. As both circuits are equivalent, so the resistance between similar nodes must be equal and will give us equation A shown below. Between N2 and N3, the resistance between nodes N2 and N3 will give us equation B. It means equation A is R1 plus R2 equals to Ra into Rb plus Rc by Ra plus Rb plus Rc, as we discussed in the back, and R2 plus R3 equals to Rb into Ra plus Rc by Ra plus Rb plus Rc is equation B. Between N3 and N1, the resistance between nodes N3 and N1 will give us equation C. The resistance between N3 and N1 is R3 plus R1 equals to Rc into Ra plus Rb by Ra plus Rb plus Rc. Let's make it as equation C. Now let's add equations A, B and C, and we will get equation D as shown in the below figure. 2 into R1 plus R2 plus R3 equals to 2 into RaRb plus RaRc plus RbRc by Ra plus Rb plus Rc. Then we get R1 plus R2 plus R3 equals to Ra plus RaRb plus RaRc plus RbRc by Ra plus Rb plus Rc, because 2 will be cancelled in LHS and RHS. Now let's subtract equations A, B, C from equation D, and we will get values of R1, R2 and R3 as shown in the below figure. R1 equals to Ra into Rc by Ra plus Rb plus Rc. R2 equals to Ra into Rb by Ra plus Rb plus Rc. R3 equals to Rb Rc by Ra plus Rb plus Rc. Now by using these values of R1, R2 and R3, we can get the value of Ra, Rb and Rc as shown in the below figure. Ra equals to R1 plus R1 R2 plus R2 R3 plus R3 R1 by R2. Rb equals to R1 R2 plus R2 R3 plus R3 R1 by R3. Rc equals to R1 R2 plus R2 R3 plus R3 R1 by R1. So using these 6 equations, we can easily convert star to delta and delta to star. It will get more clear when we solve examples in the next section. The 6 equations are this. So you can see the equation. We can transfer star to delta and delta to star. Examples of star-delta transformation. The resistance in a star system is represented with X, Y, Z, which can be seen in the above diagram, and the values of these resistance are X equals to 80, Y equals to 120, and Z equals to 40. A equals to xy by z plus y plus x equals to 80, y equals to 120 and z equals to 40. By putting this parameter in the above formula, we calculate the formula of A. A equals to 80 into 120 by 40 plus 120 plus 80 equals to 240 plus 120 plus 80 equals to 440. As we find value of resistance B, which is Zx by Y plus x plus z. Now we put values in the equation to find the value of b. P equals to 40 into 80 by 120 plus 80 plus 40 equals to 27 plus 120 equals to 147. Now we can calculate the value of resistance C by the equation C equals to yz by x plus z plus y. Putting value in the equation we get C. 120 into 40 by 80 plus 40 plus 120 equals to 60 plus 120 equals to 220. I hope I have completed my concept video in BWE. Thank you.